What if the reason you keep getting bitten has nothing to do with your blood type, your soap, or your sweat, and everything to do with a signal you're sending out without knowing it? Somewhere in your backyard tonight, a female mosquito is reading that signal from 30 feet away, and she's already flying toward you. Most people spend their whole lives swatting, spraying, and running from these insects, never realizing there's a far older, far smarter approach, one that doesn't fight the mosquito's instincts, but uses them as a weapon. Here on Next Reveal, we dig into the ideas that quietly outperform the mainstream advice, the ones almost nobody talks about because they don't sell a product. And this is one of those ideas. Instead of repelling mosquitoes, what if you built something so irresistible to them that they abandon you entirely and fly straight into a trap? It sounds almost too simple. But the science behind it has been sitting in plain view for over a century, buried in entomology journals and forgotten field notes from tropical disease researchers who were trying to solve a very different problem. Not comfort, but survival. Before we go further, if hidden knowledge like this is something you want more of, go ahead and subscribe to Next Reveal now, because what we're about to explain will change how you think about every mosquito bite you've ever had. To understand why this works, you first have to understand what a mosquito actually is. Not a pest, a sensor, a flying chemical detector shaped by roughly 190 million years of evolution to find warm-blooded animals in total darkness. She isn't guessing. She's tracking 3 signals in a specific order. The first is carbon dioxide. Every breath you exhale carries a plume of CO2 that drifts outward on the air currents, sometimes for over 100 feet. Mosquitoes have specialized organs near their mouthparts called maxillary palps, and these organs are tuned almost exclusively to detect that plume. The moment she crosses it, her flight pattern changes instantly. She begins flying upwind, zigzagging through the invisible trail like a bloodhound following a scent, closing the distance toward its source. Once she's within about 15 to 20 feet, a second signal takes over: heat and moisture. Mosquitoes sense both with startling precision, which is part of why they find you faster on humid nights or after exercise when skin temperature rises. But the final signal, the one that decides whether she lands on you specifically or your neighbor instead, is chemical. Human skin hosts hundreds of species of bacteria, and as they break down sweat and skin oils, they release compounds like lactic acid, ammonia, and certain fatty acids. This bacterial cocktail is essentially your chemical signature, and it's the reason some people get bitten constantly while others barely get touched. It isn't luck, it's biochemistry. Here's where things become genuinely interesting. For decades, public health researchers studying malaria and dengue transmission needed a way to monitor mosquito populations without relying on human volunteers as bait. So entomologists began engineering artificial versions of that 3-part human signal, synthetic CO2 sources, heat elements, and lactic acid-based lures, to build traps mosquitoes couldn't resist. The goal wasn't comfort, it was disease surveillance. But researchers discovered these traps didn't just monitor mosquitoes. In the right configuration, they pulled mosquito populations away from people almost entirely. That discovery quietly reshaped mosquito control. For most of the 20th century, the dominant strategy was chemical warfare, sprays and insecticides designed to kill on contact. It worked, but it came with a cost: resistance. First documented in the 1940s with DDT and repeated with nearly every insecticide since. The lure and trap approach sidesteps that arms race entirely. You're not poisoning the mosquito, you're exploiting a hunting instinct she cannot switch off. So how do you actually build one of these traps yourself, using the same principles researchers rely on? The first requirement is a CO2 source, because it's the signal that gets her attention from a distance. The most accessible method is a simple fermentation reaction. Sugar, yeast, and warm water in a sealed, vented container produces a steady release of carbon dioxide over several days, mimicking exhaled breath closely enough to trigger the upwind flight response. The second layer is heat and dark coloration. Mosquitoes are drawn to dark, warm surfaces because, evolutionarily, dark fur and dark skin retained heat more efficiently in the animals they historically fed on. A dark container, warmed slightly by sunlight, becomes a visual and thermal cue layered on top of the CO2 trail. The third and most decisive layer is the chemical lure. A small amount of lactic acid, naturally present in items like buttermilk, placed near the trap's entrance mimics that final skin chemistry signal closely enough that mosquitoes commit to landing rather than continuing to search. Combined with CO2 and heat, you've recreated all 3 signals a mosquito uses to identify a target. A simple one-way funnel, wide at the entrance and narrow inside, prevents her from finding her way back out. Researchers eventually asked whether this could work at scale, not just one backyard, but entire villages in malaria endemic regions. Field trials across parts of sub-Saharan Africa in the 2000s tested large-scale versions of these lure traps alongside bed nets, and the results reinforced something important. Reducing mosquito density even modestly significantly lowers biting rates. That's the part most people miss. You don't need to eliminate every mosquito in the area. You only need to give them something more convincing than you. If this kind of forgotten science-backed approach is something you find valuable, that's exactly what Next Reveal is built around. So take a second and subscribe, because there's a lot more hidden knowledge coming. There are limitations worth being honest about. Homemade CO2 traps produce far less gas than pressurized professional systems, so their range is smaller, typically a patio or single yard. They need strategic placement, ideally 20 to 30 feet from where people gather, and regular maintenance as the fermentation mixture exhausts its sugar supply every few days. But the advantage over chemical sprays is real. No resistance building in the mosquito population, no airborne chemicals settling on skin, and no ongoing cost beyond a few pantry ingredients. It works with the insect's biology instead of against it, which is exactly why it stayed hidden in scientific literature for so long. Picture the evening this matters. A summer gathering, food on the table, and instead of citronella candles doing almost nothing while everyone slaps at their arms, there's a trap quietly doing exactly what a mosquito's instincts were built to respond to. No spray, no smell, no swatting, just biology redirected. That's the real lesson here. For most of human history, we've treated mosquitoes as an enemy to be repelled or destroyed. But the more effective strategy was never about fighting their instincts. It was understanding them well enough to offer something they literally cannot ignore. The mosquito isn't tricked. She's doing exactly what evolution trained her to do. We've simply learned where to point it. For more forgotten science and overlooked solutions explained clearly, subscribe to Next Reveal. The next hidden pattern we uncover might change something in your own life just as directly as this one. Sometimes, the most powerful solution isn't the one that fights nature the hardest. It's the one that understands it well enough to work with it instead.